this video we're going to be doing the logarithmic function. So, to jump right into it, in the past we have done the exponential function y equals a to the power of x. So y equals a to the power of x. Let's say this is a 1 on the y-axis. We have an asymptote, that is this axis. So this will forever go like that, cross 1, and forever go like that. This line right here is our y equals a to the power of x. Now, the logarithmic function, let me introduce you to y equals log a of x. So, when we look at this function here, there's a couple things to note. This little a here, which is small, like it's supposed to be written like this, log a small a little lower, and then a value x. Usually when you see this log, say a number or a variable, say a variable, or let's say a number of 5, you don't see it here, but this is actually by default set to 10, unless otherwise stated, the a value. So let's note one thing down from the start, the inverse of the exponential function y equals a to the power of x, which you can also write as, let me use the other one, x is equal to a to the power of y, and the equivalent form of that would be to write y is equal to log a of x. So let's write that down somewhere. X equals a to the power of y translates to y equals log a log ax. One thing to note is that these two functions are actually inverse of them. So if we go back to our knowledge on inverse functions, remember, if we draw an imaginary line at y equals x, then we can make a reflection of the function on this axis, and that will give us our inverse function. So in this case, it will be like this. And that is our logarithmic function. So that's how it looks. Maybe we can look a little more into what it actually means. Let me write that down here somewhere. So since we know x equals a to the power of y, and y equals log a to the x, log base a of x is, they are equivalent to each other, we can say that a logarithmic logarithm is an exponent. The expression itself, say log ax, this means that the exponent that must be applied to base a to get this value of x. So, if that didn't make sense, this will, say we have, log 2 of 8 is equal to 3. So we know that 2 to the power of 3 is equal to 8. So what I was saying before is that this expression is basically giving you the exponent 3, which is here. 2 to the power of 3, 3 is the exponent here. This expression gives you whatever this equates to. When you punch it into a calculator, it gives you the exponent. If you punch in this into a calculator, you'll get 3. And what that tells you is that that number 3 is what you need to apply as an exponent to your base, which is 2, to get x, in this case, is 8. Okay, so now that we have, I want to say, a very straightforward introduction, I do want to also cover the function transformations for this particular function. So let's write out the full. Let's say we have a function of x. This is the full and there you have it. So these values that you see here are not much different than when we were doing transformations to the parabolic functions, or parabola, or quadratics. So we know that a gives you a vertical stretch or compression, and you know that if it is a negative, that means that it flips on the x-axis. Let's do k next. You know that k is actually going to give you the horizontal and you know that if it is negative, then there is a reflection on the y-axis, and you already know D and C. D gives you the horizontal that's the right word, base 10 of x. But what if we applied a factor of 2? That would actually stretch it in the vertical stretch, and then so whatever, say this would go here, this would go here, this would go there. So everything would just get stretched by a factor of 2. So you'd have, so like that would go there, that would go there, but this is still there. I'm only applying the 2, but then you have the negative 2, so you just flip that over, like so. Trying to get these points. So that gives us the negative 2. And then we also have x minus 4, which means if that's 1, that's 2, 3, 4. I'm sorry for the mess, but and that is our y equals negative 2 log 10 x minus 4. And you know we went x minus 4, we went over to the right side because the formula is x minus, I think it was c or d, I forget. But yeah, you're subtracting the horizontal translation, so since we have x minus 4, we're subtracting a positive 4. If this said x plus 4, then we would be interpreting it as this and moving over to the other side. And I think that pretty much wraps the whatever we can do with this function. You really only need an intro to this function. You don't need to know too much about it right now. One thing you can do in your spare time is look up or try to figure out, if you can on your own, the domain and range for this function. And if you can do that and put it in the comment section, then you win my utmost respect. But for now, I'm going to say that's